Hi everyone. We're looking at our latest lesson. In how many ways can we write a quadratic function? What information do the different forms of quadratic functions tell us? So in the do now, you're asked to consider the quadratic equation y equals x squared plus 4x minus 12. We know it's a quadratic equation. It has an equal sign, and the highest degree is 2. It's written in standard form because we first see the highest degree, then we see the variable with the next highest degree, exponent of 1, and we finally see the constant. You were asked to rewrite the equation in vertex form. So we're going to use the skill from the previous lesson of completing the square. So this is the original equation written in standard form. I need to create a perfect square trinomial, so I need to move my constant over to the other side. Addition property of equality. I now have y plus 12 equals x squared plus 4x. And I think to myself, what should I put in here to create a perfect square trinomial? So think for a moment. And I hope you realized we're looking at the coefficient of x. We're going to halve it, square it, and share it with both sides. So halving this, 4 divided by 2 is 2. Squaring it gives me a 4. And I'm going to add that 4 to both sides to keep my equation balanced. Addition property of equality. Now I combine like terms on the left, and I have y plus 16. I look at the right, and I have a perfect square trinomial there, so I'm going to write it in factored form. What number multiplies two factors that multiply to 4 and add to 4 is a positive 2. So x plus 2 times x plus 2, or x plus 2 squared. To write this in vertex form, I need to isolate y. So I'm going to subtract 16 to both sides, subtraction property of equality. And I finally have y equals x plus 2 squared minus 16. This is called vertex form. Let's make that clearer. Because in vertex form, you can easily see the vertex of the equation. We look inside the symbol, the parentheses, and we write the opposite of that number. The opposite of a positive 2 is a negative 2. And we copy what's outside, negative 16. This is the vertex of that equation, otherwise known as the turning point. Okay, but think about this. Is there another way to write the quadratic function from the do now? So Turi says we could take this and write it in factored form. So in factored form, if I'm looking at this, I say if this is a trinomial with a coefficient of 1, how could I factor it? What way would I go about factoring? Think about that for a moment. And you're right, you would use the AM method. What adds to 4 and multiplies to negative 12. So I know if two factors multiply to a negative, then my signs of them, one of them has to be negative, one has to be positive. They have to be opposite signs. Added is 4, so the bigger number has to have the positive sign. And what two numbers multiply to a negative 12 and add to a positive 4? And you're right, we have y equals x plus 6 times x minus 2. This is the equation written in factored form. What does that equation tell us about the graph of the function? What it says is just by looking at that, we can easily see the roots or zeros of the function. The roots or zeros of the function are the numbers that are the opposite of the ones you see in the symbol inside these parentheses. So one of the roots would be a -6, and another root would be a +2. And that means that when we graph this function, it will cross the x-axis at -6, and it will also cross the x-axis at 2. It will be a parabola, and it will cross the axis in those spots. So if you think about it, we have looked at the same quadratic function in 3 different ways. We saw it in standard form, where you start writing with the highest degree of the variable. And because this is a positive coefficient, we know the graph opens up. And just by looking at this equation, when I see the constant, that tells me that that's the y-intercept, where the parabola is going to cross the y-axis. So my y-intercept is a -12. We also wrote this in vertex form by completing the square. And this is what the equation looked like. Again, because the coefficient over here is positive, we know the graph will open up. And we can easily see the vertex from this. We look inside the symbol, inside the parentheses. We're going to take the opposite of a +2, -2. And the other part, the y value of the vertex, we copy exactly as you see it outside, -2, -16. The last way that we wrote the equation was in factored form, y equals x plus 6 times x minus 2. Again, since there is no negative sign in front of here, we know this is positive. That tells us the graph is going to open up. And the roots or the zeros of the graph are going to be the numbers that are opposite of what's in the symbol. So my root, one of them is going to be a -6, and the other one is going to be a +2. Okay, in our next page, we're seeing that there are 3 ways we can represent a quadratic function. The first one is the standard form, where we write it with the highest degree of the variable first, the x squared. Then we write x to the first, and finally the constant. And a, b, and c are real numbers. When a quadratic equation is written in vertex form, when the quadratic function is written in standard form, we're going to find the vertex by using the formula x equals -b/2a. If you remember, that's the part of the quadratic formula that's not underneath the radical sign. By using x equals -b/2a, we can find the x-coordinate. Once we find the x-coordinate, we substitute that x value into the function, and we can find the y-coordinate of the vertex. Another thing that the standard form of the equation is helpful to find are our roots. And we can find the roots by solving the quadratic equation algebraically. We set the y value to 0, and we can factor it. Or we could graph it and find the zeros of the function, where the parabola will touch the x-axis. The final thing that we can easily see from the standard form is your y-intercept. And the y-intercept is the c value of the equation, is your constant. That is where your parabola is going to cross the y-axis. So standard form is one way that a quadratic function can be represented. A second way it can be represented is in the vertex form. The vertex form would look like this: f of x equals a, parentheses x minus h, parentheses squared plus k. The vertex is the opposite of the number in here, so this would be a positive h, and then we copy exactly what the k value is outside. And a, h, and k are real numbers. So when a quadratic function is written in vertex form, we can easily identify the vertex by looking at h and k value in the equation. So the vertex form is the second way that we can see the quadratic function. Our final form is our factored form, where f of x equals a, parentheses, x minus the first root, r sub 1, times x minus the second root, r sub 2. A is a real number, and these are our roots. And when a quadratic function is written in factored form, we can easily determine the roots. Remember, another word we use for roots are the zeros of the graph. We can easily determine them by looking at this in factored form and seeing what the roots are. They're the opposite of what the numbers are in the parentheses. Okay, so pause for a moment. Make sure that you understand the difference with the three forms, and then we're going to practice using them.